we continue to focus on the design workflows. So as we move forward, we are now introducing some new features that extends the beam functionality. So here to tell you more about that is Derek Dehart, Vice President of Product Management.
Thank you, Biplab. I'm going to talk about the structural member object. So architects often start with a preliminary structural design to give themselves an idea of how much space a given structural system will require. Likewise, for commercial drawings, a structural design and the associated drawings are a requirement for a building permit. But more importantly, the structural design of a building is often now the signature architectural feature of new construction. So the structural member tool is a simple tool with 3 modes for placing all of the structural members you'll need: a column mode, a linear mode for beams, and a poly mode for free-form framing members. So we'll take a look at the attributes that are available. Of course, we have the most common types of structural members: concrete, steel, and timber. And then with those types, there's a variety of pre-configured settings and configurations. If what you have is not there, you always have the option to create a custom profile. The attributes pane allows you to set the look of the framing member at, above, or below the cut plane. So I'll add some beams to the drawing here. And as we add the beam, we'll see we're going to add a covering. And the covering is similar to the alignment also. Basically, the beams and the members can be put in 3D space next to whatever they're aligned to. So if they're underneath a slab, they can fit up against it, or if they're on top of a column, you can place it right on those column top points. Now, to those columns, I'll add some connecting beams. And I'm going to finish up the top with a curving beam. So I use the poly mode to draw an arc-based framing member. And then I'll fill in with some infill beams. Notice how the beams join to the curved arc and automatically fit. And that's a connection that's maintained, so as I stretch that arc, the beams stretch to maintain the join. Now I'll set some attributes here so we can see what types of join conditions are available. Obviously, we can miter fit right up against the 2 beams. But sometimes you want to provide a structural detail or a plate or some custom fitting in between the 2 beams. So we have the option to create some space there for the detail, but yet still maintain that connection. So that's a relatively simple structure, but let's take a look at a more interesting 3D shape. So on a front-facing working plane, I'm going to draw a curved framing member. And we'll fly around and take a look at it in 3D. And then I'm going to join that up with a beam. So as I place the beam, you can see I can switch to 3D and edit this beam in 3D space. And now as I make these join connections, you'll see that I'm automatically snapping to the 2 objects. I'm creating the fit and the mitering between the curved shape. And there, that's an early look, but I think if you use your imagination, you can see how you could use the structural member tool in your 3D designs to create signature architectural buildings.